Well, one of the questions that a lot of people ask is, how did a range guy get into studying black bears? And basically, my doctoral degree was in wildlife nutrition and feeding behavior out of Utah State. So it was sort of a natural process. And some of the questions were brought up after Pascal's presentation. I think I will address those with this data. This was a McIntyre-Stennis funded project, number 94. I have a citation at the end where you can find it online. It had matching funding from, at that time, ARCO, Louisiana Pacific, Simpson Timber Company, and PALCO. And none of those exist anymore in that configuration. So let's see if I can get the controls right here. There you go. Black bear damage to regenerating redwoods. There's been some work done on this. Greg Gusti has produced about 4 or 5 presentations and publications. Hosak was my grad student, worked on this project for 4 years, and so we produced 3 different ones. The second one is the McIntyre-Stennis 94 report. The third one is a journal of wildlife research, and this is an interesting story. We thought it would be really important to get into the inaugural journal, Volume 1, Issue 1, invited papers. Really good. That's all they ever produced. That's all it was there. Volume 1, Issue 1, with a bunch of papers in it. And there's only 6 locations in the U.S. that have a copy of that, Berkeley being one of them. They get it through interlibrary loan. And, of course, then the citations of Pascal's work that he's done recently. The objectives, oh, that's the wrong one. Okay. Mr. Bean? I am. I'm pushing the unlabeled one. Okay. Can you do it with the keys here?
Yeah.
Okay.
Is this working now?
Okay.
Yeah, now it's working.
Good.
Okay.
Thanks. Thanks, Doctor. The objectives of the black bear study were to look at document damage in 14 study sites. We had 789 trees we examined. Similar as a sampling design as what Pascal showed you, and I'm not going to bother you with all the statistics and stuff. Let's get to the important parts of looking at damage and results. Characterize tree damage mostly on coastal redwood. Compare characteristics of damaged trees to adjacent undamaged trees, similar to what Pascal did. Estimate actual yield loss attributed to black bear damage, and document the density of bear damaged trees and stands near a rotation age of about 50 years. This is the study site locations as it existed in the period of time we studied. This is 1988 to 1991. So this is sort of ancient history study, but it is an important piece of the literature that has been in an obscure journal in 6 locations in the U.S. and in a report that sat in the Humboldt room and nobody ever finds it. So I finally got them to get it up online. As you can see, we had some of the northern ones up here. We should pay close attention to these ones that are supposed to work, but it doesn't. So the ones here, 3, 4, 5, and 6, and then up 1 and 2. These are the northern ones, and it'll become evident pretty soon in terms of the concentration of bear damage when we start looking at some of the actual sites. So we had those, and then down on Palco lands in number 7, down here in the Yager Creek drainage, and so those are the areas that we sampled at that time. Well, this is typically what you see in the first few years of damage to a tree, the red flag sitting across the landscape. Some areas you can see a few red flags, and some areas I've been on up in the northern part of Green Diamond's property, you can see a lot of them across the landscape, sort of like the shirts that are red colored sitting in the audience here. Dan Oplak and I went out to photograph some damage. And so we're looking here at some black bear damage and some regrowth of the cambial tissue around where the bear had damaged it this summer we went out. And this is typical of the damage. This is a 1/4 girdling feature. We sampled 4 different girdling areas, 0 to 25, 26 to 50, 51 to 75, and 76 to 100. This is a girdling of about a quarter of the tree, featured on some green diamond landscape. And so if we look at the species of tree damage and the range of damage by study site, the implications here are redwood range from 67.4% to 100% depending upon the study site. Maximums were found at sites of Elk River, Scout Camp, Diamond Creek study sites. Douglas fir ranged from 0 to 30.8, and that was found, the highest one, in the Bald Hill study site. Western hemlock ranged from 0 to 6.6% at the Simpson 2 site, and Sitka spruce ranged from 0 to 2.1 at the Simpson 1 site. Here's an example of extensive black bear damage to a large diameter redwood, and I have a table here in a few minutes that shows answers some of the questions about the diameter. The bark characteristics allows the bears to strip bark in large swaths up the tree. They don't necessarily have to climb up the whole tree, as they can grab it and pull fairly large pieces of it. I think the maximum we found on one swath that was pulled was 120 feet. So, a large 400-pound sow can really damage the tree. This is what happens after a few years, 100% girdling. The tree is dead and basically no commercial value. We look here at the variables that we studied, whole list of variables on the left of the screen. And the ones that were most critical that we determined were the first 4 species, DBH, percent girdle, and distance to road, similar to what Pascal found, the distance to road, and then the basal area. The others were important, semi-important, or actually unimportant. This is another example of black bear damage with high girdling featured way up the tree. As we talked about, there's no girdling at this point. The bear went up to get to a certain DBH, and then they started working the tree up as far as they could take it. Here's some bear damage on some fairly large DBH trees. This one on the left is about 3/4 girdled, and the one on the right was 100% girdled on green diamond land. The black bear damage into 14 study sites. We can see over here on the first 3, Elk River, Scout Camp, Diamond Creek, had 100% damage to the redwoods. And then we go down to the others, we can see fairly low percentages, down to about 67.4% on the redwoods. And then same for the Douglas fir, for the western hemlock, and finally the Sitka spruce. So the concentration of damage is really into the redwood stand and very little to the other species. They do hit other species. This is Doug fir that's been damaged, but not extensively, as you can see by the scar tissue there. And then we look at number of damage to available redwoods, and this is an interesting relationship to what Pascal was talking about with density. And so if we look at remember the areas in the north of the map, over here where we have Klamath 1, Klamath 2, Simpson, and Big Lagoon, these are the ones that have fairly high relationship between damaged trees and available trees. So same thing, we went to the nearest neighbor and looked how many available trees were around the damaged tree to get that. And so over on the far 2, Klamath 1 and Klamath 2, we actually had a situation where they're almost at the same level as what's available. This is the percent of damage by location. We see over here that Klamath 1 and Klamath 2, again, are the largest, followed by Simpson and Big Lagoon. So again, more that northern part of the Redwood Range in Humboldt County. This is a table showing the the number of black bear damaged trees per hectare or per acre, depending upon what column you like to look at. On 14 sites, I was told by Dan that foresters like to see it on an acre basis, scientists like to see it on a hectare basis. Okay, so we have over here number of damaged trees, 65, mean of 65 per acre, with a range of 179 on LP to 10.3, 10.4 on the Cornell site. So quite a variability across the sites. Fairly high again, Klamath River 1 and 2 at 100 and 104, basically, trees per acre. This is a density, percent redwood and DBH of black bear damage. And if we look at this, we can see that that these are for the ones at 59 to 61 years, rotation age, so a different set of study sites that were at that rotation age. And we can see the percent of redwood that was in the stand, and then the DBH of those that were damaged. Average DBH was about 64, the highest being at 76. So they do go after the larger trees. At that time, we didn't understand or didn't have the idea of what Pascal has done with the phloem thickness. And that's an interesting attribute that would be worth further study. So some of the conclusions from the McIntyre-Stennis report that's produced in 1993, mean density of 26.5 damaged trees per hectare, or 65.48 per acre, for the stand studied between 98 and 91. On 18 of 13 sites, redwoods was damaged in significantly greater proportions than it was available in stands and studied. Damaged redwoods had larger mean DBH than the average redwood tree found in the stands studied. And there were more redwoods in the 76 to 100% girdle category than there were in the other three girdle categories of 0 to 25, 26, 50, 51 to 76. And most bear damaged redwoods were found along roads and trails, ease of access for them, than were statistically suspected in the stands studied. Continuing our discussion on conclusions, mean annual bear damage to regenerated redwoods was 6 trees per hectare per year, 13.4 trees per acre per year. This may represent a serious economic problem. Bear damage at rotation age indicated that bear damaged redwoods was highly variable, but redwoods comprised almost all of the damaged trees. Yield loss due to bear damage projected to rotation age about 50 years was highly variable and averaged over 21%, with the highest being at 54%. Pre-commercial thinning was not determined, as we did not do replicated studies like what Pascal was doing with paired plots. Personal communication during the period with different individuals working for the companies we were contracted with suggested that the damage decreased the further south you go in Humboldt County, and was virtually less active than in Mendocino County. Most of it associated with the northern part of Humboldt County and in the southern part of Del Norte County. I took some information from recent Mad River Union, which I'm sure all of you read. There was an article about the harvest activities on the Arcata Community Forest, and used pricing that Mark Andre had put in there to calculate out in today's dollars, using the data from we did in produced in that period of time, the early 90s. And so if we look up here, the average loss for all stands shown was over $22,000. The board feet lost per acre averaged over the 13 stands was 21,000 board feet. And so 16% of the volume on the data we collected, 16% of the volume of any stand was lost due to bear damage. This represents a fairly significant impact to a commercial enterprise in forest production. And with that, I'd like to thank you and note that Dan Opalak from Green Diamond helped me, and Sarah Hanna from the Department of Forestry and Wildland Resources helped me. And at the bottom, this is just now up in the past few days. You can find McIntyre Stennis number 94 at that particular link if you want to get it.
Thank you, Ken. Time for a question? Yeah, Brad.
Do you have any handle on what the blackberry entity was on your site?
No, and Pascal and I have talked about that. It would be an interesting future study like he discussed to corroborate with the wildlife faculty and do some telemetry work on where the bears move, because there's some speculation, Leonel's not going to like this, but some speculation that the park is a refugia for them to go and do their breeding, and then they move out in the springtime to a commercial forest. Yeah. I like it. He and I used to play basketball together in college.
Okay.
So that's a good question. It's something that needs to be answered.
Well, thank you, Ken. Very good.